both work for GE Healthcare. So if you have gone to a hospital in the US, you probably used our equipment. So for us, bugs mean somebody dies, right? Because it's the monitors that the doctors use to give you medicines. If your BP shows wrong, he gives you the medicine, right? So it's not like we can postpone bugs or live with bugs, right? It's very crucial, like bugs are real bugs, right? So we'll talk about this. So all these days, past 2 days, we've been hearing about all CI, DevOps, cloud, all these things. But how many testers in the audience? 1, 2, 3, okay. So rest of the guys, this is going to be great learning for you. So this is a technique called pairwise testing. This is not pairing. This is a classic testing technique that any tester, if he graduates from test school, would know, even in the waterfall world, right? The reason why we don't know about this is because we're concentrating on all the big stuff, but we're not concentrating on the basics. This is the reason why we wanted to take the topic a little down towards the basics, and then we can build all this nice stuff that the other team talked about, you know, all this process of going to CI, continuous deployment. But so that's the reason why we've chosen this topic. It's going to be great learning. So how many of you feel that we test enough? Can anyone say my code has no bugs, including developers? Sir, my code is 100% clear. You cannot break my code. So Sen Kamer, who's one of the big testing experts, old school testing computer software, anybody has read the book? He says a tester is a guy who's never satisfied with the amount of testing he's done. Just like the police say there is always an evidence, right? The testers always believe there is always a bug. Do you believe or no? Even the best products, iPhone, anybody knows what bugs they have? There's a lot of bugs. iTunes, horrible. Okay? Amazon.com, million bugs. Whatever you think is the pinnacle software has a lot of bugs, right? Okay, so here's the scenario. This is the wake-up scenario. Everybody take a paper, pencil. Okay? First one gets an award. Okay? What is this? Flight cockpit, right? Okay, so think about 80s movie, Tridev or Stezab or something. The villain has 10 of these buttons, only 10 of these buttons, wired in a particular sequence, which when you flip them correctly, will turn off the bomb which is going to go off in 20 minutes. It is tied to the chest of the heroine. She is sitting in the plane, and you have to flip the switches correctly, 10 switches, okay, right here. Okay, 10 switches, you have 20 minutes, you have to figure out the correct combination, and heroine will be saved. You can have the heroine. Come on, who can do it? Only one guy. Right? Do we agree? This is how we find bugs. We want that magical combination which the customer will hit, so that we will find the bug before he finds. Right? Is this possible? Okay, so just to give you an idea, right? There are, like, say, take Skype, for example. How many operating systems? Right? How many versions of operating systems? How many updates? How many bits? 32-bit, 64-bit. Hardware, Lenovo, Dell, blah, 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 HP. How many combinations? Just Skype. How are they testing? How many combinations? And I'm just talking about a BVT scenario. Normal, login, call user, establish conversation. Normal, I'm not even talking about out-of-the-box scenarios. Do you think this is humanly possible? Right? Okay, now we are talking about automation coverage, unit testing coverage. Now, even if you do manual testing, can you cover 100%? I can give you as many resources as you want. You have 2 weeks to certify the build. Now, how can you tell I have tested 100%? You are feeling lucky, that's it. Right? You somehow hope the customer does not hit that scenario. By the way, this is Rajinikanth for people who don't know. If you don't know him, come talk to me. Okay? Right? So this is Sen Kamer. Please note down this name. Go online, he has a lot of material, free PDFs on testing. So he says these are the 4 fundamental challenges of software testing. And point number 1 is our concern. Complete testing is impossible. Agree? Yes, great. Testers misallocate resources because they fall for the company's process myths. Okay, aka politics. Okay. Third one, test groups operate under multiple missions, often conflicting, rarely articulated. Hey, can you test this, man? Hey, 2 minutes, man, I have to leave. Please, sir, please, this, sir. Then I'll go. How many times you have been interrupted like that, right? And then PO suddenly says, guys, stop what you're doing. We have to restart the sprint. Right? All this happens, right? The last one, okay? This, so till last year I was manual tester. Now I became automated tester. I can Python, I can do, sir, C sharp I cannot do. Right? These are challenges we face day in, day out. No point in lying to ourselves. Right? This is a place where we don't have to impress each other, right? Okay, so let's talk about point number 1. Complete testing is impossible, and this is the reason why. And I'm pretty sure each one of you can give me more reasons. Right? First of all, what scenario the customer is going to use itself is not in our control. One of my testing gurus used to tell me, think that a monkey is using your machine. Pull out the network cable. See what happens. Right? We face so many scenarios. How many times your phone gets dialed because you put it in your pocket? Has anybody tested that scenario? Do you think there are guys walking in Apple with phones in their pocket, making sure it doesn't dial? It happens. It's a very common scenario. It's called butt dialing. It's a common scenario. Right? So testing every possible combinations. Right? Testing every possible sequence. Right? Can you send the same image to 4 WhatsApp groups at the same time? Copy paste 1, copy paste 2, copy paste 3. It's normal, it's because that's what we do most of the times on WhatsApp, we forward, right? So we need, why can't we forward to multiple groups at the same time? Normal user scenario, somebody didn't think about it. Anyway, so test every hardware software combination. Think about the phone business here. Every city in China probably has a phone, and Korea probably every street has a new phone. And if you have to develop an app for a phone, how much testing do you have to do? So test every which, try to use the program. I have a 3-year-old baby, and you should see how she uses my phone. It's literally abuse, not use. She'll stamp on it. Right? So these are scenarios we cannot think about, but we have to embrace ourselves from being, otherwise you're going to be on the headline, and you'll become another Yahoo or Lycos or Tripod or go down the drain. Right? Next. So here is the motivation for pairwise testing, and since we are in the healthcare business, it is not WhatsApp. Here we miss scenarios, patients die. Right? It's like testing an aeroplane. These bugs we can postpone for next release. Can you do that in an aeroplane? An unknown error occurred 0x080000C. Please contact your system administrator. Imagine the cockpit, such an error comes, what will that guy do? I had one GPS, in the US, one of those first GPS. It led me to some Timbuktu and said server not available. And it's like 12:30 at night, there's like serial killers everywhere. What can we do? Right? So these are bugs that we cannot compromise on, right? So these are 2 great researchers. They have said that 98% of the bugs tested by all possible pairs of parameter settings. So this is the keyword, pairs. Right? So this, please note this is very important. Can we move on? So this is just one of our, and I can't talk about the product, but basically one of our testing conditions. This is how much we need to think about the total number of combinations we have. Think about the Rajinikanth scenario, right? Right? So do you think even if I automate, I'll get an answer in 1 week? And we are saying, sir, 3 days testing will be over, sir. Sir, only 3 hours we can certify the hotfix. Reality is scary, actually. Yeah. So this is some analysis which we thought is from Sam Kamer again. We thought it will be very useful. So simplest bugs in the system are generally triggered by a single input parameter. Instead of string, he'll give an input of integer. And we won't have tested it, it will break, it will blow the system. So assertions, very important. Developers, assertions, very important. Next simplest category of bugs consists of those dependent on interactions between pairs of parameters. How many people develop microservices here? Or service, APIs, web services? How many inputs do you have for your main method? Is it a REST service or a 6, 7, 5? Depends again. So it's not one, definitely, maybe more, right? So this is the reason why we chose this topic, is because this is the need of the hour right now. We say, sir, API testing very easy. We don't need Selenium or Cucumber or anything. We just need unit tests, and we're going to do API testing. Only half an hour is required, sir. API testing very easy. But actually, if you do it really with all the parameters, it's a lot of work. So we see the pairs of parameters. The first one is single input. Second one is 2. Third one is 3 or more parameters. So the number of parameter combinations increases, the number of bugs found goes down. Are you with me here? So single input variation, more bugs. 2 inputs, next. 3 inputs, more. 4 inputs, lesser. 10 inputs, it will be least. The possibility of finding a bug.
In terms of the complexity, that's going to be the most complex. As you go, as the number of interactions increases, the complexity increases. But at the same time, the benefit that you get out of it is very limited. Right? The 1 and 2 interactions cover maximum defects. That is 98% of the defects. Okay.
So this is that in a graph, actually, the same thing. So what this says that is, pairs, when you test in pairs, you find the maximum bang for the buck. You find max bugs when you test in pairs. Right? Even if it's a 10 method, you test in pairs. Okay, that is what we are trying to talk about, and that's why it's called pairwise testing. And yes, sir. No, what they did was they took out bugs, lot of bugs from the archival, figured out why it was happening. So it's a study that they have done. There is a whole PDF on that, white paper on that on his website. I can provide you the link also. Yeah.
They're there in the references.
So this is the pairwise testing combination. Before we go into this, any questions so far? Now, does this apply only for functional testing? Should apply for unit testing also, right? Yes or no? Yes or no? Yes. Even the simplest public method that you write, your database access layer, anything can use this technique. This is a classic testing technique. Now my colleague will take over, but I'm available for questions as well.
And does it only apply to software, this technique? I mean, just a guess. You can even apply this technique to any hardware system also, right? Any system that takes some inputs, you can apply this technique. Okay, so the pairwise technique, it's all about testing or figuring out the combinations in which 2 inputs interact at a time. So actually, I mean, no amount of theory can help you understand this technique unless we get into the example. So in a nutshell, like it's an approach. It's a combinatorial testing technique which will execute a pairwise data set in order to find defects. Okay, I think we'll move further. We'll get into the example. So let's take an example. Imagine there is some system, hardware or software, web service or microservice, whatever. It takes 3 inputs, x, y, z, and the value for each of those inputs are given in the brackets, like a, b, x takes a comma b, and y takes c, d, and then z takes e and f. So now, to test this particular system, how many test cases do I need to write? Okay. Yes, like if you want to test this system thoroughly, you will have to come up with 2 into 2 into 2, that is 2 power 3, 8 combinations. So with 8 combinations, you will be able to test this system. But imagine, I mean, this is 8 test cases is pretty small number. But as we increase the number of inputs and the values each of those inputs take, then the this number can get exponentially high. It can go into lakhs, crores, and which even if you have all the automation in place, you will never be able to finish the testing in one lifetime, right? So that is the amount of testing that is actually there in all of our systems. Just that we are not at all aware of the quantum of testing, and we tend to go by the whatever is comfortable for the testing team, and that is how we encounter crashes at the customer sites, because some combination which has more probability of triggering a defect might not have been tested at the in the development life cycle. Okay,
just to give you one example, let's say we have taken multiple choice answers, right? Have you done that? Right? People who are good in math can answer this question. Let's say there are 10 multiple choice questions. Each one has 4 options, 1, 2, 3, 4, right? Now you don't know the answer for all 10. Okay, think it's your entrance exam or something. Now you have to do guesswork. Now you have to choose out of the 4 for all 10. Which will you choose? What number will you choose so that you get the maximum probability of getting the answer right? Simple math. All 10, 4 combinations, 4 values each. So can I choose first question first, second question second, third? No. All same. Why? That is what this parameter, that's why this Pairwise testing works. Because when you alter more than one parameter, the chances of getting the answer right is lower. People who are doing very well in academics won't understand this. Okay, go on next.
Okay, yeah.
Just to give you an example.
Yeah. Move on. Okay, so we talked about the 8 combination or 8 test cases to test the previous system, right? Which took 3 inputs, and each of those inputs took 2 values each. So if you were to list out all those combinations, here it is, T1 to T8. These are all the test cases that I need to execute in order to test that particular system. Now let us apply the pairwise technique on this, and then see what is the reduction that I would get from this. One. Okay, so the idea here is you can get rid of any test case. I mean, you can make any row redundant in this table, provided all the combinations within that row, within that combination, are covered by one other combination other than itself. So that is when we can make the row redundant. So that means I don't have to execute that test case, but still I will be able to cover 98% of the defects that might be there in this particular system, right? So let's start from T2, and what are all the pairs available in T2? It's AC, CF, and then AF, right? Just one. Yeah. Okay. One more. Okay. So now we see that AC is covered in T1, right? So I put a tick against T1, and then go on. CF is covered in T6, so I'm going to tick that as well, and then the last combination AF is covered in T4. So that means all the pairs available in T2 are covered in at least one other combination. So as a result, I can strike out this T2. I don't have to execute this test, right? So
any questions?
This is the very this is the very crux of the pairwise testing. If you understand this, then probably you understand pairwise testing technique. Yeah.
The question I had was, does this assume that you need to have a fair amount of the systemic view before you start getting into?
Anytime you start testing, it's better you have a systemic view before you start testing. But to specifically answer your question, it is definitely a white box testing technique, not a black box. You understand what's going on inside. But then think of these as data types, right? So think of it as A is integer, C is string, and E is like float or something. Then we can still work with this even if you want to do a black box technique. But it is better we know the systemic, how it works inside quite a bit, end to end, so that
fact,
we
it
can
is very
figure-
mathematical, like it is. So that is why I said it can be applied to any system, hardware or software.
Another
Okay?
question?
Any other question? No. Actually, I think you are getting it wrong. So basically, see, in the previous slides, Arun talked about when we did a analysis of all the medical software failures and try to find out the root cause of all of them. We figured out that that's mostly because of pairwise interactions. Like if I had done this pairwise interaction testing, probably I would have been able to catch 98% of the defects that were found once the product was in the customer place, once it was released. So here we are interested in the combinations, the combinations of the input values. So AC is one such value, one such pair, and CF is another pair, and AF is one more pair. So if I ensure that, basically if I take out this if I do not execute this test case, since I am executing T1, T4 and T6, that bug, if it which was which would have been caught through T2 will anyway be caught through either T1, T4 or T6. That is how it is. So the same bug which will be triggered by executing T2 will also be triggered by T1, T4 and T6. That's the idea.
No, so you're talking about 3 pairs there,
Yeah,
right? So you're
but
talking about 3 items here, C with B, C with F. We're talking about 2 right now.
pairwise.
Pair is
that
two.
That is why it is pairwise.
My question is, how can we make sure that C works with A if these two passes?
Okay, so to answer your question, through that research it has been found that it is not really required. That particular combination that you are talking about, that is not required, because maximum bugs are covered through, of course, like that 2% which we are missing out, that 2% could be this test case. That is unavoidable. But with this, if you do, when we apply this technique, with the amount of reduction that you get in your the total test cases is very huge. So
See,
probably 1 lakh combinations can get reduced to just 20 or 30 with pairwise technique. So which means with just 20 or 30 test cases, you are able to cover 98% of the defects in my system.
See,
So that means another 2%, there are still chances. Right?
Just to add
That
to whatever
might
he's
come
saying, right? Just to add, we anyways cannot execute the entire suit. We are going to have to prioritize. This is calculated prioritization,
Yes.
right? This is
It's
not
a
random.
calculated risk.
This is not random picking or say I like to run these things. This is easy. So we do a lot of this. I don't have to tell you who does it, but internally whether you're doing a calculated test case prioritization or you're just picking up on random and praying to God, right? But this is a calculated prioritization where we take a guess, just like the answer sheet I said, right? Where we do a calculated guess on saying that this is the highest probability of finding bugs. And this is a technique that has been around for a while, and like you said, it's been applied for hardware as well. But this will come to the caveat in the end. Okay? Yes.
Yes. Mm-hmm. 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 Okay. So, yeah. Yeah, basically to you make use of this pairwise technique, you have to be very sure about 2 things. What are the parameters to my service or to my system, and then what are the values each of those parameters would take. See, sometimes age is a parameter, for example. Age, we know, like it is usually an integer when we code it, but integer can take a long range of values, but we are not going to test all of them. Here we are going to use some other techniques like equivalence partitioning, boundary value analysis. We know that the bugs are likely to occur around the boundaries, right? So that is how first we need to figure out what are the values I am going to pass, or what are the values I am going to use in order to test this particular system. So in the case of age, probably you would choose a value between 100 and 120. Sorry, 1 to 20, 1 to 120, right? Not beyond that. So you will have to first maybe do a equivalence partitioning, say 10, 50, 60, 80, 100, 120 like that, and they become around 6 or 7 values for that particular input. So that is, first we need to figure out the input parameters, and then the values each of those will take, and then apply this technique. It will give you a reduced subset, which you can use to do the testing.
So every user story will have its own testing, right? So depending on what the sequence in the user story, you'll have to follow different test pattern for that.
And it is purely a mathematical thing, a mathematical technique. So it doesn't really take care of all those logical sequencing and all. But as I said, pairwise testing technique comes with some caveats, which we'll talk about in the end. If you think that some particular sequence is more important for me, then you should definitely include that as part of your test case suite, right? Okay, so can you, yeah.
We are selecting the pairs which needs to be tested and avoided.
Mm-hmm.
Do we need to calculate which are the most appropriate?
Can you park your question for a minute? Because once we undergo this exercise of pairwise reduction by hand, and then see what is the reduced subset, then probably your question will get answered. Meanwhile, can you think of other? I think you already come back. Can you come back? Come back. Yeah. One more. Sorry. Yeah. Can you? Sorry, he has already shown the answers, but still, can you try and see what other combinations from this, out of this 8, can we get rid of by using this same technique? I think it requires a little bit of paperwork. Otherwise, it's hard to just say by just looking at the table. So you'll have to go through some paperwork and then figure out which other combinations can we get rid of. So basically, going by the same thing, first you need to go through each of the combinations and then find out all the pairs within that combination and see if if those pairs are being covered elsewhere. If they are not covered, then that has to be included. I mean, this combination has to be part of your test set, or otherwise it can be made redundant. So that is how it is. It requires a little bit of paperwork. Okay. I can take down the table and then see, follow the same technique that I used for this particular T2. I can't get rid of T1 now because it is being considered.
You can reduce more.
You can reduce further. By employing the same methodology, we were able to get rid of another 3 test cases or 3 combinations. So the reduced subset is further will be this. So by applying pairwise testing technique to the original list of combinations, from 8 I came down to 4. So by executing these 4 combinations, I'll be able to uncover 98% of the defects in my software, in my system, right?
Yeah, so we are talking about exhaustive testing. It could be a part of your regression suite, your BVTs, your smoke tests. It's up to you where you hook them up. But we're talking about exhaustive testing. Say you say I am tested, the story is done, right? We are assuming that you tested all possible combinations, or rather the PO, when he signs off on the story, he assumes either the developer or tester has tested all the possible combinations. So yes, it could be a part of your regression suite, especially when you do changes, when you want to do an impact based testing, is when this will be very applicable.
From in the previous example, we came down from 8 combinations or 8 test cases to 4 test cases, right? So that was like 50% reduction, which is good but not great, right? So, but look at the reductions that you would get as the number of parameters increases and the values for those parameters also increases. So for a system which has got 7 inputs, and each of those inputs are like on and off kind, which means they will take 2 values. There are 128 combinations, but your reduced subset will give you 8, which is much better, right? Maybe 10, 12 times compressed. And similarly, for a system that takes 13 inputs and each of those 13 inputs have got 3 values each, in that case the amount of test cases you would end up writing is this many, 1,59,000, that number. And then when you feed this to a pairwise testing tool, then you would get just 18 test cases.
So when there are 40 inputs.
So with 18 test cases, you are able to uncover most of the defects, which is good, right?
When there are 40 inputs, do you think a reduction is possible by hand?
No way.
You'll go crazy.
Yeah.
Yes, sir. Yeah.
Yeah. Fortunately, we don't have to do this by hand. There are plenty of tools available in the market which will help us to know. You just need to feed what are your inputs and what are all the values that each of those inputs will take, and it will give you the reduced subset. So we'll come there. Yeah. These are all the tools. So there are plenty of tools. I think the text is not so visible.
Yeah, you'll have the slides on slide share.
Yeah. Yeah. Basically, like the
we need to reduce these tools.
Yeah.
Yeah.
Actually, I mean, the most popular among these are like pick from Microsoft, PICT. Are you aware of it? Okay, you can probably take a look at it, PICT. And the one which we use at GE is called Test Cover. Go further. Yeah. So this is the tool we use at GE. This is a licensed one, and the license is pretty expensive. Although it looks like it is just some simple algorithm, but it is not so simple. It is definitely a very complex algorithm, and the licensing is pretty expensive for us.
Yeah. How many developers here? So think about writing a tool to do what we did.
Yes.
How complex is the logic?
Yeah.
That's what this tool does actually.
That is how we have so many tools. They are selling. They are trying to sell their pairwise algorithm. Okay. So basically, this tool is developed from Bell Labs research, and they claim it is the most mathematically optimal among other tools. And then it works based on just 3 things. It takes test factors, which are nothing but input parameters, and test factor values, that means the input parameter values, and then some constraints. I'll come to the constraints when we get into an example, but these are all the 3 things the tool will take as an input in order to process and give you a reduced subset of test cases. Yeah, that's the link. You can go there to have a little more understanding of what the tool does. So let's take an example. So imagine you are trying to build a website, and
10 minutes.
Yeah, we are trying to build a website, and that has to work across all these configurations. Say it has to work against XP, Vista, Mac OS, and Linux, and then it has to work against 3 different display resolution, low, medium, high, and then connection. It has to work on both Wi-Fi, DSL, cable, or LAN, and then browser. It has to work on 4 different browsers, and it has to support 3 different applications. So if you were to ensure your website works across all this, it requires 576 configurations. See, nothing but like multiplying all the number of values, it will give you 576 configurations. So that means you need to have 576 setups in order to test your website. So which I'm sure it is going to be very tedious, right? Both in terms of budget, time, right? Okay, so go on. Okay, so the test cover request is pretty simple. As I said, the first line would be the header, just the request header, just to identify the request, and then followed by the test factor, nothing but all your input parameters, names, okay, and then followed by an hash symbol which represents a partition. A partition can have 1 or more blocks. I will come to that example later, but that is, partition is immediately followed by the values each of those input parameters take. For example, operating system is taking XP, Vista, Mac OS, Linux, and display resolution low, medium, high, and so on. You'll have to map the values, input values, to corresponding test factors. Go on. So when we feed this into the tool, this is the output that we get, and there are how many configurations? So from 576, the number of configurations got reduced to just 16. So with 16, we are able to cover most of the defects, right? Okay, so go on. Yeah, just go 1 second. Just go back a little. Sorry. So here, if you observe, there are some invalid combinations. It says, you know, Mac OS and then IE, which doesn't really work, right? Like you can't install IE into a Mac OS. So that is why I should be able to say that, you know, there are some invalid combinations, so ignore them while calculating the subset, right? Go on. Okay, so that is why we have this something called constraints. So each constraint can be represented through a block, and that block is represented with the symbol plus, followed by some comment, and then basically, like, you need to split your request such that we know that, you know, XP, Mac OS, Linux, and Vista, they can support both Firefox and Opera, right? And under that, you will be listing all the values, right? Except that for the browsers, we are listing only Firefox and Opera. We are not including IE and Chrome, right? IE and the other one. Okay, so and then in the next block, we know that XP and Vista will support, in addition to Firefox and Opera, they also support IE and Safari, right? So that is what it represents, the second block. And then the third block, which is Mac OS, which supports only Safari. So we will put that in the last. And then when you feed this to the tool, we'll get the reduced subset, which will be like 20. So earlier it was 16 without constraints, but with constraints it got increased. Okay, so in this result, you will not see any invalid combinations. That is how you take care of you know, some invalid combinations which are not meaningful, right? Okay. Okay. So as I said, like this technique, pairwise testing technique, it's an age-old technique, but just that kind of neglected from the testing community. Very few people are using it, but as I said, as we saw in the beginning, only one hand went up when we asked who heard about pairwise testing. So I think there is a need for awareness about, you know, creating some awareness around this tool, this technique, so that we can do better justice for our testing, right? So this technique is not a silver bullet that can solve all the testing problems. As we say in the beginning, from the beginning, we have been saying it will cover only 98% of the defects. So the other 2% will be missed out even if you employ this technique for each and every requirement in your application. So basically, this technique will not work if you choose wrong values, right? If the inputs, the identification of the inputs and their values, if that is not correct, then this technique is going to mislead you in terms of some combinations which might not be of any value. Okay, so that's the caveat. That's a danger available within this technique. We just need to be aware of it, and then many a times, like, the bugs will not show up immediately. Like, once the product is out, even if you do all this testing, the bugs will be there, but they don't show up, right? It takes some amount of time for the system to show up. Some internal corruption will be happening and will not be aware of it, and they will show up at the customer side sometime, right, down the line. So that is why, like, we can't guarantee about those kind of defects through pairwise testing technique. And then so the high use, like, although the pairwise testing technique might not give you the combinations which are more frequently used at the customer side, because it is purely a mathematical technique, and it doesn't care whether the customer is going to use some scenario, some combinations more frequently than others. So it is up to the individual testers to be aware of that, and then include if there are any such high use test cases, high use combinations that the customers will be using, you should definitely include them in addition to the pairwise subset that the tool gives you, right. So with that, these dangers are not only available for pairwise test, are open for pairwise testing, they are also with other testing techniques also.